Good day to one and all. I am Dr. S. Ramanakumar Joga, Assistant Professor, Tripoli Department, Dadi Institute of Engineering and Technology, Anakapalli, Andhra Pradesh, India. And I am here to present my paper ID 103 and title is Fault Detection and Classification in PV Systems using MRA, DWT and AdaBoost classifier. These are my contents in my presentation: introduction, literature review, problem formulation and methodology, results and discussions, conclusions and future scope, and also major references. So, coming to the in recent years, the power demand through the renewable energy sources are increasing from day to day. So, among all these renewable energy sources, solar photovoltaic system is more reliable, efficient, and economical in nature. However, so these PV systems may suffer from the intermittency of environmental conditions. So with these PV system may come across different fault conditions like open circuit faults, short circuit faults and partial shading condition. You can see here in the figure, a figure consists of a different solar PV modules connected in series parallel connection, and these PV array system undergone many faults which are unavoidable conditions. So these unavoidable conditions may result to the faults. So these faults are open circuit faults, short circuit faults, and sometimes partial shading. And these faults may alter the PV and IV curve and subsequently decreases the power output. So it should be important and very crucial task to detect these types of fault, and we have to inform to the relay. So for doing this particular task, we have done the literature. In the literature review, we have studied few papers. Like first paper is detection, classification, location of open circuit and short circuit faults in SOTO and solar photovoltaic array, an approach using single sensor. So it is a paper that published in IEEE Journal of Photovoltaic in August 2023. So in this paper, particularly PV fault is put forward by obtaining all the module voltages assisted by a simple low cost relay with a single voltage sensor. And these in this particular method they have detected the open circuit faults and short circuit faults in a series parallel solar PV array. And the second paper is classification of photovoltaic faults using PSO optimized compact convolution transformer. So this paper was published on 2023 December in IEEE Access. So in this paper they have used the deep learning method to detect the faults in the PV. In the third paper, fault detection of photovoltaic array based on machine learning classifier. So they have used so many different data mining techniques like KNN, SVM, and decision tree machine learning classifiers to detect the fault in PV array, and also they classified the various faults that occur in the PV array. And the last paper, the dropout and prune neural network for fault classification in photovoltaic array. So in this paper also authors designed a neural network architectures to detect the faults that occur in the PV array system. So after studying the literature review, we formulated the problem. We have done the mathematical modeling of the PV array system. You can see here the various PV modules are connected together in series and parallel and formed a PV array. And the NS is refers to the number of series connected PV modules, and NP is referred to the number of parallel uh, strings in a PV array, whereas IA represent the output current of the PV array, while VA represent the output voltage of the PV. So coming to the methodology, so this proposed method mainly contains four steps. So in the first step, we have to collect the voltage, current, and power data from the measurement units like voltage sensor, current sensor, and data loggers. And from these things we have to collect the data, and then we have to pre-process the data, and finally we have to extract the meaningful features from this data. In this proposed method, we have used MRA DWT method to extract the meaningful features in the voltage and current signals. And also we have labeled the features, and finally these coefficients are fed to the AdaBoost classifier to detect and classify the faults that occur in the PV system. So this is all about the methodology that involved in this proposed method. So coming to the results and discussion, so to validate the proposed method, we have took the 3 by 3 PV array and we simulated in MATLAB, and also we have conducted the experiment in real time environment. So a 3 by 3 PV array with various types of fault is shown in this figure. You can see here a figure consists of a 3 by 3 PV array with common faults like OC, open circuit fault, and a short circuit fault, and a partial shading one. And we have extracted the meaningful features from these voltage and current signals here, particularly current signals. So in this, first we what we done is we took a current signal and we decomposed this current signal through MRA discrete wavelet transform, multi-resolution analysis discrete wavelet transform, up to 4 levels. We have took Dabuchi DB2 as a mother wavelet, and we took the current in every case, like current in normal position, normal situation, and current during the short circuit fault, and current during open circuit fault, and current during partial shading conditions. You can see the decomposition of these current signals at various faults, and later we have labeled these futures, and we have fed to the AdaBoost classifier. Here you can see the scatter diagram for the fault classification. The blue are the open circuit fault data, and the red belongs to the partial shading data, and the green belongs to the short circuit fault data in the scatter diagram. So after feeding these data into the AdaBoost classifier, so there are 515 data sets that make up the classification issue. So these data sets include data on open circuit faults, partial shading, and short circuit faults. So from these AdaBoost classifier, out of total 515 data sets, 400 data sets have been as open circuit fault, and 91 datasets have been classified as partial shading faults, and 21 datasets have been classified as short circuit faults. And it is also determined that the AdaBoost classifier has an overall accuracy of around 99.41 classification accuracy. So you can see the confusion matrix here, and we have tested these particular simulation results by conducting in a real-time experiment. So the experimental setup for the fault investigation is shown in this particular figure. The Bhaskar Solar 20-watt PV modules are strategically positioned in a 3 by 3 series parallel PV array for the purpose of experiment setting. So after taking the data from the data loggers, and these 439 data sets are collected from the various types of faults, and these faults are fed to the AdaBoost classifier. So the results of this classification shows that out of the 439 data sets, 377 data sets are classified as having an open circuit fault, and 43 data sets are categorized as having partial shading, and 17 data sets are classified as having a short circuit fault, and 2 data sets are classified as having a classification. Here you can see at the open circuit fault, one data set is showing it is a partial shading, and one data set of short circuit fault showing it as a misclassified as a partial shading fault. So the overall accuracy of the experimental setup by the proposed method is around 98.54%. So if we compare the experimental results with simulation results, the simulation results we got around the classification accuracy of 99.41, and the experimental results we got around 98.54. So there is small slight accuracy difference is there, but the thing is the proposed method efficiently detected the fault in the PV error and also classified the fault in the PV error. And we also compared the proposed method with other methods that are available in literature, found that the proposed method gave efficient results compared to the previous method that existed in the literature. Although Stockwell transform plus SVM method gives 100% accuracy, but that particular method was not validated through the experiment. Coming to the conclusions, in conclusion, the integration of multi-resolution analysis, MRA, and discrete wavelet transform techniques coupled with a robust data-based classifier presents a powerful and effective solution for fault detection and classification PV array. That is already proved from the results that we obtained in the previous slide. The AdaBoost classifier, known it for the ability to handle complex data sets, enhances the accuracy and reliability of fault detection and classification. The proposed method is validated on both simulation and also through experimental setup. We have seen the experimental setup also, and investigate develop advanced future for the time frequency domain. So in future, the main future scope is we have to investigate the advanced techniques for the future extraction, and also we have to develop the advanced techniques for future extraction in the time frequency domain. So this may include exploring other wavelet families, extending MRO approaches, or combining the multiple feature extraction methods to capture a more comprehensive set of features that could improve fault detection accuracy. This is the future scope of this work, and these are my major references. And thank you. Any